Welcome to Flow Stars, candid conversations between Dr. Peter O'Toole and the big hitters of flow cytometry, brought to you by Beckman Coulter at BitesizeBio.
Today on Flow Stars, I'm joined by Bill Telford, Head of NCI Research Flow Cytometry at the NCI Centre for Cancer Research, and we discuss how he started forging a career in flow cytometry from an early age.
It was my sport rather than playing, football or something like that. I was 15, 16, 17 years old. So for in the US, it would be sort of 10th, 11th, and 12th grade.
His extensive involvement in both national and international cytometry education programs.
The program has trained thousands and thousands of students. So it's been a wonderful outreach program.
And providing instrument technology and training to institutions in need around the world.
We donate old equipment. We've been doing it for over 20 years now. And so we now have almost 30 instruments, I think it's now 30 instruments in the field. We try to train our recipients to fix their own equipment.
And bizarrely, how he unwinds after a hard day's work.
One little project we've done in my lab that has leaked over into my home very much is what we call the make your own cytometer.
All in this episode of Flow Stars. Hi, I'm Peter O'Toole at University of York, and today on Flow Stars, I'm joined by Bill Telford. Bill, how are you today?
Oh, fine, thank you. Doing well.
Thanks for joining me today. But I'm going to ask the very first question is, how on earth did you get into flow cytometry?
Okay, well, my background, I've always been a science person. I've loved science from as long as I can remember. I did, in the US, we do what are called science fairs, local and international science fairs. I did all that stuff. And I met my first flow cytometer as an undergraduate at the University of Rochester. Leon Wheelis, who is one of the kind of founders of flow cytometry, was there. And he had a one color flow cytometer. This is back in the early 1980s to do cell cycle. And everyone was abuzz there about this instrument that could measure DNA in a single cell. So I heard about it and I went over to look at it and I was very intrigued. And that's kind of how I got started. So I used cytometry in many of the, in my graduate work since then. But ultimately I kind of kept staring back to it as a profession, as something that maybe I could do full-time in my job. So that's kind of how I got started. And it's a junction of technology and biology, and I really enjoy it quite a bit.
So back at those science fairs, certainly in the UK, that's not a big thing that we do. I've noticed, yes, that they're big on science fairs. What sort of posters, these science fairs, you usually have a bit of a display with a poster or some information?
Sure, absolutely.
What was on yours?
Okay, so you would do a project that would take, probably months to do. And mine involved at the time using antibiotics as an insect control measure to try to disrupt insect digestion and maybe control the insect. And this was, of course, not a very original idea. It was being done in a lot of areas at the time. But it involved, growing up the insects, testing the bacteria. At the time, there were no genetic methods. Everything was all biochemical tests, finding out what bacteria they had in them, and then using antibiotics to try to disrupt that. And I did it for 3 years, and it was well received. Now I go to I judge science fairs, and the projects are so much more sophisticated. And the kids are so much smarter. At the time I competed, but now there's no way I could compete. It's the level is so much higher than it used to be. But then you'd present your work in a poster, and they'd have judges who were university professors and from industry and such. And they would come around, and there were local and state competitions, and then there was an international competition. And I just love it. Was my sport. I'm not a sport person. So this was my thing in high school as a secondary student, rather than playing, football or something like that.
That was my next question. How old were you?
I was 15, 16, 17 years old. So for in the US, it would be sort of 10th, 11th, and 12th grade, right before college.
How are you getting these antibiotics? How are you doing the assays?
I went to my doctor and explained what I needed them for, and he Wrote me the actually, he got me the injectable form. He got me the clinical form. I had a lot of help from the people, I had a couple of university professors who helped me out. I had a researcher at a local ag station. So I had a lot of people, professionals around me who either took pity on me or humored me and were willing to help out. And I couldn't have done it without them.
I'm loving the idea. And I'm now thinking of projects I could get my children to go to the doctor and get me all sorts of different drugs.
Yeah, absolutely. Of course, this was the 80s. It was this is now 40 years ago. So, which is very sobering when you think about it.
One of the classic questions, I guess, one of my stock questions is, what did you want to be when you were young? But I guess you wanted to be a scientist. Where did you see? What was your vision of a scientist then?
I did always want to be. I was very strange child. I always wanted to be a scientist, and you'd look at the Louis Pasteurs and the Alexander Flemings and these people who stumbled on great discoveries, and that's sort of what your image of a scientist is, maybe when you're that age. But it was just always fascinating to me. It was, and I'm very grateful. At the age of 56, I'm still not bored with it. I still like doing it. I was always afraid maybe I'd get tired of doing it, and that hasn't happened yet. So,
wow, I didn't realize you were 56, Bill.
Yes, I am.
Well.
Becoming an old man very, very quickly.
Don't say that. I'm coming up on your heels. So you can't say that. Still young. So 56, still looking quite fit, looking very healthy. So you must be doing some exercise.
Oh yeah, no, I backpack. I used to rock climb in my youth. I used to run in my youth. I did some things that were semi-athletic.
So rock climb, backpack, used to run.
Yes.
But you just had a knee operation?
I just had a knee operation, yes, which is kind of a rite of passage for middle-aged men now, is to get their knees replaced. So I've got a knee full of titanium alloy and plastic right now, and it's working okay as far as I can tell.
And that doesn't trigger the sensors at airports?
It probably will. And they're you get a card saying you have it, but they still don't like it. So what are you going to do? But we'll find out. I have not been cleared to travel on an airplane yet. They get all worried about blood clots and things like that. So hopefully by September, I'm planning to take an international trip in September, and we'll see what happens.
So so they used, I believe, it was robotics operation.
Yeah, it's sort of interesting because they now, so much surgery is switching over to robotic systems. And as my surgeon said, kind of defensively, I'm still doing the operation, he said, but he said the robotic system gives them a lot more information, positioning, kind of pressure on the implant as it's going in. He said, I get a lot more information out of it when I use the assisted systems. And he said that the procedures are much more uniform as a result. But it was interesting. They wheeled me into the operating room, and you're still awake because they have to do a spinal block. So you still need to be conscious for that. And I'm looking around, and there's like a workbench, and there's racks of metal, jigs and clamps and things. And I'm thinking, this doesn't look that different from my workshop at home. It had a kind of a blacksmith feel to it. So I think there's still a lot of kind of skill and artisanal, activity that goes on here in putting these in. But as my surgeon said, my surgeon was one of the ones who pioneered robotic technologies in our area, and he said, I don't do any other type. He said the technology is getting so much better, and the outcomes are getting better. So he said, even from 5 years ago, he said, you'll have a better chance of success than if I had done this procedure 5 years ago. So the technology is really moving, like everywhere, it's moving forward. And
I'm glad you clarified that when you said the technology is getting better, because I was worried that the technology is getting better, but still not as good as man.
Well, I think knees are tough. There's so much stress on them. There's not as much, hips have more support around them. So knees are considered difficult because they are, it's sort of where the rubber meets the road. A lot of stress is put on them, and historically, it's been a procedure that's been a little dicier just because of for a lot of factors. But it's encouraging to see that this is a, like all areas of medicine, they're not stuck. They're pushing the boundaries of it. So far I'm impressed. So far it seems to be working out very well.
That's good. And so I'm intrigued. How many blood tests did you have before they allowed you to do surgery?
Yeah, they do a full metabolic panel. They do they check your clotting time, of course. They want to make sure you don't have any MRSA bugs in you. So they look for antibiotic resistant bacteria. And in fact, before the surgery, they give you topical medications and such to try to reduce the possibility that you have these bugs on you, because that's a big problem for orthopedic surgeries as people get post-surgical infections. So they did an EKG, they have a whole laundry list of things they do, but it's all very, well organized, and they are very good, I think, at assessing risk. I was not under general anesthesia. They gave me a spinal block, they gave me a nerve block, and then they just gave me some propofol to knock me out to make me go to sleep. But I was not under a general anesthetic. They try to be very conservative about putting you under too far if you don't need to be. So you wake right up. I was awake. The surgery ended at 1 p.m. and I was awake by 1:15. I was already waking. I could see the clock on the wall. Yeah, it's amazing.
I was curious by the test to know if they used any flow cytometry in it, and the
that's why you're
developing
asking.
Technologies, developing assays, and now you're benefiting from those.
Yes.
For your own safety.
Not that I'm aware of, but I think when you work, as you work in this field too, it's flow cytometry is just one of many clinical tests out there, and there are common threads that run through all of them. I see a kinship between what we do in analytical chemistry, clinical chemistry, and things like that. And of course, it's always great when a research test becomes a clinical test, when suddenly you're something that the field has worked on now can benefit patients and can form a real clinical marker for something like that.
I still get excited when I get blood test results back, and some of them are flow cytometry ones, thinking,
yes, absolutely. I know it's
check these properly.
I've gotten differentials and things like that. I'm like, ooh, I could interpret this. Yeah, it's always nice to see connection to the real world.
That you always want to be a cytometrist. A
scientist.
And
some type of
the bio side, I presume, being as you were looking at antibiotic resistance and antibiotics and the effects on insects and so forth. And you went into, so that's where you wanted to be. You got into your degree level.
Yes.
What was your degree in?
My degree was actually in microbiology. I was at the University of Rochester in the state of New York, and they had a biological science program where you could specialize in one of 5 different areas: molecular biology, microbiology, genetics, and so forth. So you chose an area of specialization. But it was an interesting place to do a degree, because actually it was not a medical institution where I was at. A lot of very basic molecular biology, gene regulation, and things like that were being done there, using protein sequencing and gene sequencing to establish a hierarchy hierarchies of bacteria and other things were being done. This is back in the 1980s. So we had sequencing technology at that point, but it was very hard to do. It was really kind of a critical time in molecular biology, because suddenly a lot of these technologies were becoming more widely available, and they were being employed very vigorously to study problems in biology. So it was an interesting place to do it. I got a good grounding in the molecular side of things. But the medical school was right across the street, and that's where I took a volunteer position when I was a freshman in my first year of college, and I worked in a cancer biology lab, and that's where Leon had his flow cytometer, his very old cytometer. It had 8-inch floppy disks. Probably no one who's listening to this program will remember the old days of data storage, but 8-inch floppy disks, and the computer technology was very primitive and very error prone at the time. but it was very exciting because it just sort of clicked with me. I said, oh, wow, this is where engineering and physics and biology meet. This is you've got to be able to understand all of these things to be able to do this.
So what was your first flow cytometer then?
My first flow cytometer?
Yeah.
Well, actually, I went to work as a technician for a couple of years after my undergraduate degree, and we had a BD fax scan, which was brand new at the time. This machine came out in the late 1980s. It was the first small multicolor cytometer, as you well know. So it was really a critical machine, not just for our field, but for medicine in general, because suddenly flow cytometry wasn't something that you had to have a big expensive machine that needed a specialized operator to run. It was something anyone could run. But actually, when I did my graduate degree, I worked on a much older instrument, an orthocytofluorograph. I went to Michigan State University, which is an agricultural school in the American Midwest. And we had an instrument that was old even by standards then. But it was a great machine to work on because everything was out in the open and you had to get in there and adjust it and tweak it and align it. And it was a terrific instrument to learn on. So I've worked on the old ortho machines, the old BD sorters like the Fax Star, the Star Plus, the 440. I'm old enough that I wasn't around for the birth of flow cytometry, but I was around for sort of the childhood of flow cytometry. So it's one of the only advantages of age is it gives you a historical perspective on the development of the field. I also got to interact with a lot of sort of the old boys of flow, the probably 15 or 20 scientists who really founded the field. And one of the great things about flow is it's not a very old field, which means a lot of these people are still around. And it was a terrific, it's an honor and a privilege to be able to do some things with them because they founded the feast basically. And they saw it as their job to pass that information on to the next generation, to keep the technology moving forward.
So on the side of passing on knowledge and education, so I presume you're talking about the likes of Paul Robinson, Howard Shapiro, for that. But it's now being passed on to yourselves and the other generations to now be those advocates.
Yes.
And I think in the developed countries, there's a lot of knowledge, there's courses, there's a lot of access material. But I know through Isaac as well, you're doing a lot for the education of flow cytometry, not just in the US. So tell us a bit about where you are trying to educate and how you're achieving that.
Absolutely, sure. And this is something, you're involved, you and Karen and many others are involved in too. ISAC, which is the International Society for the Advancement of Cytometry, which is our professional society, places a lot of emphasis on education, particularly international education. So again, I was very lucky. I was in the right place at the right time. Back in the early 2000s, I got involved in the Indo-US flow cytometry education program that was started by Dr. Attar Krishan at the University of Miami. He was running these cytometry workshops in India. And I was very lucky to get associated with that. And since then, that effort has expanded tremendously. It's now part of ISAC's organization. We've done dozens and dozens of workshops all over the world in many countries. We have faculty all over the world. Michael Ormerod, who sadly recently passed away, was an integral part of that program. He did distance learning in cytometry long before distance learning was even called distance learning, and he was very heavily involved in that program. But we have faculty all over the world. We have faculty in China and Australia, India now, many participants in this. And the program has trained thousands and thousands of students. So it's been a wonderful outreach program. And I think one of the things that Krishan did a great job of is when we would do a workshop in a country, if we had someone there who was particularly good, someone who was great in organization or was a good teacher, he would kind of grab them and say, hey, join our club, be part of our workshop. So the Indian faculty would start going to Turkey, and they start going to China and others as part of these international teams. So it's a very international effort. It's not focused on any one particular country. And it's been a privilege to be part of it.
So you sent some photos, which I presume are part of.
Absolutely. Sure. So this is our group in Nepal. This is Tribhuvan University. It's the Central Department of Biotechnology. The gentleman on the right, this is Dr. Krishna Manandhar. He is the department chair of this group, and he's a member of ISAC. He's actually a member of the Live Education Task Force, which is part of this international program. This was actually involving an instrument we installed there a few years ago, a Faxcalibur over here, but we've done a number of workshops there. We've done several live ones. We did 2 virtual ones during the pandemic, and we'll be back in October, actually, to do another one. So this is very representative of the type of group that we work with. Nepal has been, they've been a wonderful group to work with. They do a lot of immune monitoring for diseases like dengue. So they have a real need for flow cytometry, for research cytometry, and they're tremendously motivated. And they have a patient population that they have good access to. Yeah. So they've been wonderful folks to work with. And this has been repeated by not just by me, but by many others all around the world.
And this was 4 or 5 years ago. I think
it's probably 2017. Yeah, this is actually this was actually just a few months ago.
You can see by the face coverings that this is more recent.
Yes, this is you. Yeah, you look for the masks. This is Dr. Dina over here. Dina runs a program called the Center for Health and Disease Studies in Nepal. This is also in Kathmandu. We also gave them a Faxcalibur flow cytometer. So this was our installation over here, and this was just back at the end of March. This was the trip where I decided to get COVID, actually.
So you got COVID
while I was in Nepal, yes. But they took wonderfully good care of me. I quarantined in my hotel, and the local head physician at the hospital called me every day, check in on me. And the hotel delivered my meals, and it was actually, they took tremendously good care of me. But this was after I was out of quarantine. We set up an instrument for them as well. So
we have this discussion in different communities: flow cytometry, microscopy, and the reuse or the passing down of instruments, because obviously instruments are robust. Even our facility, we had the Cyans in our facility for, oh gosh, possibly 18 years.
Right.
No, correction. Maybe 20 years.
Yes.
No, 90,
yeah,
18,
they're
19
old enough.
years.
They're almost old enough to drink.
And they were still fit for purpose for, it was 9 colors. Yes, it's not the all singing, all dancing latest systems that we have. Many, it was perfectly, gave them the answers that they needed. So it's more than good enough. And actually, we've moved ours into our teaching labs now to give them extra resource there. But is there a challenge of taking systems that the commercial companies no longer support, putting them into countries that are not so wealthy, don't have necessarily good access to engineers or spare parts? How are they coping with keeping these things running over time? Because that must be a major challenge. It's a challenge for us to keep systems that are off the shelf serviced running. Over there, they haven't got the same support network because they haven't got the same number of systems, so it's not the same number of engineers, and the parts are now limiting. So how are you managing that?
Well, just to give a little background, we have a program at the NCI where we donate old equipment. We've been doing it for over 20 years now. And so we now have almost 30 instruments. I think it's now 30 instruments in the field. They're on all 6 inhabited continents. But it is an enormous challenge because we're not well funded, first of all. We are giving used equipment. And as you say, the equipment is getting older, and the parts and other things are becoming an issue. As you say, you can't imagine another instrument technology where a 20-year-old instrument would still be useful. Imagine a next gen sequencing system or something, they go obsolete every 2 years. But these old flow cytometers are still very useful. And if you only need to look at a few things, they were wonderfully built. They're just as sensitive as the new machines. The only difference between the old and the new is we can just do more simultaneous tests on the new machines, but the old ones are still very useful. So what we do is we get the old equipment, we refurbish it, we ship it abroad, and then we try our best to support it. I have a stock of parts. I have connections in the industry where we're able to upgrade a lot of our equipment. So for example, the old gas lasers, whenever we renovate a machine, we just yank out the old gas laser, put in a newer solid state laser and ship it with that. So we're doing our best to try to keep these things running, but it's a challenge. And during the pandemic, it was of course a major challenge because we couldn't travel anymore. So we had equipment breaking down left and right, and there was nothing we could do about it. But you're right, they can't get access to service. Even when they can get access to service, it's generally very expensive. And the equipment is aging, absolutely. What we're trying to do now, and I know you've worked on things like this as well, is to try to get new equipment into labs, modern equipment, rather than the old stuff. We see the old stuff as a stopgap. It's a way for labs to get started on this technology, to begin to do some research, to get their people trained up, but then they should be getting something modern. And what we're looking at and what ISAC is looking at now is trying to get the manufacturers to provide newer equipment that we can then support, as we've supported the old equipment.
Yeah, no, you're absolutely. We were very fortunate, and Paul Kay was part of a large proposal which funded into East Africa and supported new instruments, European funding. So we're very lucky to have got that funding to support that. But even then, I think there's challenges there's cultural differences in the way that some universities operate, and the sharing. We're so used to now having core facilities. So you've got a successful core facility. How many cytometers do you have?
Oh, we have 9 or 10 at least now. Yeah,
and
which is very normal.
Comes to use your cytometers, and there's this economy in numbers. Everyone's using it. It's got expertise that can now be sustained because everyone's using that expertise. Whereas, if we go back 20, 30 years ago, people used to have their own cytometer in their own lab, and culturally, there's more places in the world that want to have their own badge. So everyone collaborate with them, and it's not open access, and that makes it harder to sustain. So how are you finding that when you're putting your systems in? How open access are they really when you go in?
Sure, absolutely. I mean, we because we are a core, and we believe in, I believe passionately in the core cytometry, in the core facility kind of ethos, in terms of making the equipment as open as possible. So we try to find recipients who are willing to do this. The Nepal facility is an excellent example of this because they are very open with their equipment. They're very willing to share, and they've been very generous with other groups, since this is a country that really doesn't have a lot of resources in this area. So we try to identify recipients that are going to do this. But you're absolutely right. A lot of these institutions will get the machine in and then build a barbed wire fence around it and say, well, we're not letting anyone get access to this. Partly because they're possessive about it, partly because they don't want anyone to damage or break it. It's a valuable resource, and they're very sensitive to this fact.
Gosh, I think that's a problem even in the UK historically, and there's still a few places I think that still have their own instruments, and they won't let others use it purely because if they break it, their research stops. Because it's so difficult sometimes to get repaired. And sometimes it's not a case that they're not open access. It's a case that other academics don't necessarily want to use it. They want it is still a badge to have their own. It's taking time. I think, to change that. I think we're very fortunate in the groups that we work with of being very open, but I'm quite sure there's other facilities that are popping up around them, just because that's the way funding is falling out.
Sure, it is.
India, where else are you helping besides India and Nepal?
Okay, so well, we have a large presence in India, and I will just say, one thing we and our Indian colleagues have tried to do is encourage the formation of core facilities, because it's not a common thing there. And one thing that ISAC is terrific about is recognizing the value of core facilities and the people who run them. They have this shared resource lab, emerging leaders program. We've had a number of awardees of this in India who are running cores. But in terms of training, we've done a great deal of it in Asia, and I am not doing a lot of it. This is a large group of people like Paul Hutchinson in Singapore, the Australian group. They've done training in Singapore, Vietnam. We're very fortunate to have good colleagues all over the world. Indonesia has been, we have terrific colleagues in Indonesia who have really taken the initiative, and they just organize their own meetings now. They include us, but we don't have to do anything. They just set everything up on their own. There's a very powerful cytometry society there. So certainly Southeast Asia, China, which really doesn't need our help. They're doing terrific science on their own, but we have good connections in China where we've done a number of collaborative workshops with our Chinese colleagues. We're getting more into South America now. It's an area that really there's no excuse for it. We haven't paid a lot of attention to, but now we have good ISAC membership in South America. People like Mariella Velati, sorry, who is in Uruguay. She has really taken the lead in organizing workshops down in the southern horn of South America, in Uruguay and Paraguay and Argentina and other places. We have instruments going down there now. Mexico, Central America, Eastern and Central Europe. Tomas Kalina, who's in the Czech Republic, is an ISAC executive member, and he is doing a lot of work. He wants to basically do a workshop in every Central and Eastern European country is his current goal. We've done workshops in France. We've done a lot in the U.S. We're not just doing them abroad. We've done a number in the States as well. So it's an enormous organization now, and we have terrific representation all over the world, where the local groups just they do all the work. If we're lucky, we get to go, but they do all the work for it.
So I have maybe a strange question. Just thinking while we're talking about how core facilities are really the thing of the last 20 years or so. Mm-hmm. And the way they've sort of taken it from the individual labs into a shared resource. Do we see a risk that there's a whole generation of scientists now, academic scientists, that don't remember the days without shared facilities? Mm-hmm, mm-hmm. That they might start to want their own instruments again?
Sure. Oh, it's already happening.
so this is really interesting, isn't it? Because if you go back, academics were quite happy to put their instruments into shared resources, to core mm-hmm. facilities, because the responsibilities, the difficulty, the downtime, the lack of access when theirs is broken and they need to get another system. Whereas putting it into one facility, everything's there, it's equitable, they're not responsible, there's someone to train, someone to fix, someone to chase engineers. And now there's this whole new generation coming through that's never seen these problems and thinking, well, wait a minute, I'm having to fight, I haven't got the exact system I want, I'm having to fight for time maybe sometimes. I'm going to get my own. Wouldn't that be easier? Mm-hmm. How are we going to stop sort of going back full circle to come back again? Because no question, the most equitable way, our funders really understand this. And that's our biggest strength. But locally, if people are getting local funding, how do we stop this? Once you've got little islands being formed, it can mm-hmm. affect the core structure.
Yeah, it's tough, and it's something. I mean, I'm at a large institution where we do have many large labs that say, you know what, maybe we've crossed the threshold where we should have our own instrument. And I try very gently to fight it, if you will, to say, to just say, look, there are many advantages to using a shared instrument facility. The instrument will be quality controlled every day. If it breaks down, we'll have an engineer in within a day. It's more economical in the long run. We have many stories of people who have gone out, gotten their own instruments, and it hasn't worked well.
Yeah.
because the instrument is down a lot, and the person, the postdoc or the research fellow who learned how to run the machine has now gone on to another job, and they didn't pass that information, their knowledge on to anybody. But it's something, I mean, for running a core facility, and this too, it's something we kind of are constantly waging a low-level battle about to make sure that the instrumentation remains centralized. And I think as things get more complex, particularly for things like cell sorting or high dimensional flow, which is a lot harder, you really want to have a core of experts. You want to have people who this is what they do. This is all they do, and their purpose is to assist the scientists around them. But you're right. I think the funding mechanisms. I've been on some MRC, large instrument review panels and such, and they really demand that equipment will be accessed by a large group of people. If you're a individual investigator going in with a proposal, you better have 9 or 10 other scientists on that proposal too, with very clear objectives and a clear plan about how it is going to be shared, not how it's just going to sit in your lab. And in the US, the NIH shared instrument grant program is the same way. The best way to get your grant refused is to not demonstrate that it's going to be a shared instrument, and you'll get turned down immediately. So that helps us a great deal, fortunately.
The NIH are there, certainly BBSRC, MRC, EPSRC. So the UK funders are very much there. Absolutely.
Yeah.
But then you'll hear an academic say, yes, but actually I will use it 100% of its time. Surely the argument is, yes, you'll use it 100% of the time, but wouldn't it be better to have 200% over here when you need it, and when it breaks, you've got I think most do get it, but I'm just a little niggle that it could go backwards. And you said how the complexity is increasing, so the importance of having experts. But unfortunately, I don't know if that's the right word to use. Manufacturers are making them so much easier to use that actually to walk up and even do your own cell sort now. I've got to say, the culture SRTs, someone can walk in, almost not have had training, and it will walk you through it and you'll sort. And there's a lot more in the interaction with the data and the gating, but a user can use it. And I think there's a danger that people will forget not appreciate the skills that are needed to get good sorts, because the instruments enable you just to sort so well. That's a compliment, by the way, to the SRT. It's then down to the user's intelligence of how to strategically gate their data.
Sure. And I mean, the system you bring up is an excellent example of this, because it is probably one of the few systems out there that has, I think, successfully created a cell sorter that can be used by many people. It's user friendly, it's well designed, but I think it could still sit in a core facility. And people can come in and use it the way they would use a benchtop machine. But again, trying to convince the powers, I can convince our money managers and things like that this is a great idea. But if I have a big shot investigator who has 20 people in their laboratory, in their mind, they're thinking, well, I ought to have my own equipment. And if I were them, I'd probably feel similarly about it. So I think it's our job to really convince them that that they'll benefit from having equipment in a shared facility. And what we've done a number of times is, in equipment that is in individual labs, after it looks like it's not going well, we'll go to them and say, we'll maintain your equipment for you. It won't really be in our core, but we'll come in, we'll do a QC every few days. We'll kind of quietly kind of ghost our way into their labs and put the equipment under our aegis, even if it's not officially there. There are different strategies you can use to try to deal with this problem.
I'm going to change tack a bit. Running a core facility always has its challenges. What would you say is the biggest challenge that you face? What are the most difficulties in running a core facility?
I mean, there are many difficulties. One of them is, for me, and I've been in the field for a long time, and there's a whole new generation of flow people who are now coming up behind me, is that data analysis has changed tremendously. we kind of lagged behind the genomics and proteomics world for a long time in perhaps not being so sophisticated about our analysis, because we weren't looking at very many simultaneous, elements, parameters, as we would call them. That has certainly changed in cytometry now. We're looking at 40, 50 color data. We're now adopting the same bioinformatics techniques that are used in the genomics and proteomics world. And for me, it's been a real learning curve, because it's something that I didn't have to deal with as much earlier. So getting up to speed on that, being able to do probability state analysis and FlowSOM and phenogram and all these other technologies has been a real challenge for us, keeping current in the technology.
It's a very different skill set.
It is.
It's the acquiring the data, the technical expertise, instrumentation, but now the analysis is a completely different toolbox. I would say. So after a hard day's work, you've got the stresses of learning all these new challenges and return. What do you do at home to relax?
I still do a lot of outside stuff. My wife and I, we backpack. I am a science geek though, and actually during the pandemic, a lot of our, my sort of lab thing, sort of the stuff that I was doing related to cytometry, but not strictly part of my job, ended up migrating home. One little project we've done in my lab that has leaked over into my home very much is what we call the make your own cytometer, where we have built a teaching instrument. There it is. Yes. We actually stole this. Don't worry, you're okay.
I'll go with the computer.
Trying to get down underneath it. We actually stole this idea. This is not our idea. Back in the early 90s, the Los Alamos National Labs flow group, which was Los Alamos was one of several birthplaces of the flow cytometer, decided that a great way to teach cytometry would be to actually have students build a machine with their own hands and get it running, a working instrument, not a model. So they built a system like this, and it's been a fixture ever since in the annual training courses in the States, the ones in New Mexico and Maine, the annual course, which is now, I think, going on its 45th or 46th year. So we love the idea. I got to build it when I was a student, and it was a blast. It's the most popular lab in the course. So we decided back in about 2013 to build a road system, one that we could pack in a suitcase and take to international workshops. So this is what it is. This is actually a slightly older version. We now 3D print a lot of it. But it's something where I've gotten to sort of cross that dangerous barrier between your work life and your play life, and gotten to learn a lot of new technologies like 3D printing and electronics and coding and things like that to try to build a system. So that is a working system. It's fully functional. We've taken it, I think now to 13 countries. We've done over 25 workshops with it. We put together a video version during the pandemic, which was kind of a mixed success. It's something that really you want the students to get their hands on. And the students the younger ones absolutely love it, because this is very comfortable turf for them. They grow up now, building drones and RC cars, and they code, and where it's newer for me, for them, this is a very familiar technology. So they have a blast with it. And we have one machine in India. We've built, I think, 4 or 5 of them now. So we have an instrument in India, and we're going to try to put one in Europe, I think, too, where the instrument will actually sit there. We'll have people who know how to teach it. But when we go to meetings in these areas, we don't have to bring the system with us. We can we'll have one on site. But it fits in 2 suitcases. It weighs under 45 kilos, so in 2 suitcases, so it can go as checked luggage. We don't have to ship it in. We can fly with it as checked luggage.
That's still pretty hefty.
It is hefty. Well, we're trying to get it down in weight, and it's actually that's the old weight.
Well, where's the weight in it? I'm just reopening it. Obviously, you can get rid of your sheet.
It's like packing a suitcase. You don't think you're carrying very much, but you can't get the lid shut. We've tried to design it in ways that are there's some 3D printed components here. The base plate is carbon fiber. There's one company in the world that makes carbon fiber breadboards in Germany. They're the only people that do it. So they've built breadboards for us. And otherwise we have our computer and everything else, but it goes into the case, weighs something, it's like building a satellite. You try to get the weight down as much as you possibly can. So we're now, it's mostly 3D printed now. We have a little, and what's wonderful too is that the technology now allows this. Lasers are tiny now, and they're getting cheaper and cheaper. We're still facing challenges in the electronics and the software and such, but there's so many cool off-the-shelf, maker components now. Things like Raspberry Pi and Arduino and Teensy. You can go on Amazon and buy all sorts of materials and components. You can 3D print so many things. The time really is right for this. And what I really hope is other people will do this. We don't want to be the only people doing this. Other people should be working on this and bringing their expertise to bear. So we're trying very hard to encourage other groups to take this idea and run with it and do something with it.
So moving on. So you've got, at home, you're now making cytometers.
Right. Which is a very slippery slope. When they start showing up in your living room, that's a bad.
Do you read a book or TV?
Yes, of course. I absolutely read a book. I absolutely read books. So I love good science. I know you can't get away from science, but I love good science writing. I collect it. It's wonderful to see not just scientists, but journalists and others do high quality science writing.
Nonfiction.
Yeah, sorry. And but I love to travel. And doing the instrument donations has been a shameless excuse to do that, because when we give an instrument, I can then go to the country and set it up and train the people. And it's been a wonderful thing to be able to do.
Who's funding the trips out though? Because obviously that's an expense in itself. You're talking about fixing them. Who's actually funding because the air tickets are not cheap.
Sure, absolutely. No, we have the NIH funds the restoration. We've been doing this for 20 years, and we have some funding mechanisms for that. They're actually very supportive of it. I was surprised to learn 20 years ago there's actually a mechanism. The U.S. government actually has a mechanism in place for donating equipment abroad. There's in the U.S. government, there's a form for everything, and there is actually a form for this. So I've had wonderful support from inside my institution. We have some foundation monies that have funded the travel and also some of the restoration efforts as well. We're trying through ISAC right now to try to sort of get it away from the US government and move it more towards something where I don't have to be working there for it to happen, and so that others can be involved in as well. But we just try to keep the costs really, really low. And we are, we travel, we fly coach, and I stay in guest houses in India whenever I can. We make a very conscious effort to try to keep our financial footprint very small, and of course now our carbon footprint as well, which is a problem because you have to fly into these places. So, but as you know, ISAC is very focused on this. Rachel Arrington, who's our new president, ISAC president, is very, very concerned about this. She's very socially conscious, and we're going to try to work with find ways to try to minimize this impact as much as we can. But we just do it on the cheap, and we try to train our recipients to fix their own equipment. And with some limited, not everyone's so interested in doing that, but to make them as self-sufficient as possible, so they're no longer relying on us. If something breaks, I can just ship them the part and they'll take care of it.
We should talk after. I've got some ideas around that.
Yeah, absolutely.
Remember that, and we'll have a chat afterwards about some different ideas just around that. Certainly the engineering side as well has just come to us. Some other questions. Some quick fire questions.
Sure.
PC or Mac?
Oh, I'm a PC person. I have nothing against Macs. In fact, I was in college when the Mac Classic, the Macintosh, the original 1984, the year when the original Macintosh came out, and Apple showered our campus with free Macintoshes to
Okay.
try to take over our hearts and minds. And I was very impressed, but it's just been PC. It's been more sort of open architecture platform accessible, but I have nothing against Macs.
Okay.
Yep.
McDonald's or Burger King?
Oh God. I can't eat them anymore because I'm trying to keep my weight down, but flame grilled burgers are better than hot metal. Hate to say it. Burger King wins.
That's a Burger King vote.
Yeah, but I won't eat at either one now, so it doesn't matter.
What if you had a takeaway? What would be your go-to for a takeaway?
Oh, for takeaway food, we have a wonderful chain in the States. I'm not sure if it's in the UK. It must be in the UK. Chipotle, which is it's Mexican, well, kind of Mexican, but it's sort of a nouveau Mexican, and it's delicious. The food is very high quality. They seem to have a lot of they've had some well publicized food poisoning incidents, although I don't think they're any worse than any other takeaway chain. But at least in the East Coast, we love Chipotle. It's good food.
Tea or coffee?
I am not a tea or a coffee drinker. I don't drink coffee at all. I drink tea because I travel a lot internationally, and you kind of have to. You go to India and you have masala tea, and it's delicious. But I have to go with tea. Although I'm actually a diet soft drink drinker. I drink obscene amounts of Diet Coke or Pepsi, doesn't matter which. Yes, I know it's bad for me, but it's my tea or coffee. It's very American.
Coke Zero, so Coca-Cola Zero or Pepsi Max?
Oh, there's so many now. I prefer diet. Actually, I'm not right wild about the Coke Zero or Pepsi, Pepsi Max or whatever it's called. Okay. There's a small cadre of us that love the diet soft drinks, and I apologize for it. It's no excuse.
It's okay. Beer or wine?
Beer or wine? Oh, beer, definitely. I love beer. Again, I can't drink it. Don't drink much anymore because it's got too many calories. But I love a good beer.
You can certainly tell you're reaching an age where, oh my goodness, everything's gonna stick.
I know, right? Exactly. Oh, I reached that age a long time ago.
Chocolate or cheese?
You have to worry about staying alive. So I love a good beer. I love a good bitter or a good ale. Absolutely. It has to be a good one. Or what's the point?
A good dark, strong alcohol.
Yes,
definitely.
Yes. None of this Budweiser nonsense.
Chocolate or cheese?
I never met a cheese I didn't love. Ooh. Absolutely love cheese. The stronger and stinkier, the better. I love chocolate too, though. But actually, cheese, if I had to live without one or the other, I'd rather live without chocolate. I love cheese. I absolutely love cheese.
If you were to go to a conference or be taken out as a guest, what would be your ideal food that they could serve in front of you? What would be like, result, that is just perfect? What would it be?
Ideal food, like ethnic food? Ethnic
no, just anything. If you're away, someone took you out to eat.
I'm a carnivore. I like meat. I really do. I try to eat less of it, but I think one thing we do well in the States is we make a really good steak, and I love that. I grew up. My family is from Chicago. My father would go to this, when he was young, would go to the stockyards and buy his meat literally fresh, and he passed that on to me. So I love a good fillet. Again, not a good for you, but here we are.
And so from that, if you were to have something put in front of you, what would be your nightmare food to have put in front of you?
Oh, there are foods I don't like at all. Pickles, olives, a lot of fermented foods I'm not wild about. My wife loves them, so it's a big problem for us because she adores these foods. But I hate to say it, some of the microbiological foods, and yet I love beer. And I love cheese, which is intensely microbiological, but those are the foods I'm not wild about.
Okay.
Yeah.
Are you an early bird or night owl?
I'm sorry, say again?
An early bird or a night owl?
Night owl, totally night owl. Night owl, absolutely.
So what time do you head to bed?
I'm better now, but I'd head to bed around midnight, 1 a.m, generally. But I could stay up. I get working and suddenly it's 3 or 4 in the morning. and I don't know where the time has gone. So I've always been from childhood, I've always been a night person. I'm a vampire.
Okay.
Definitely. Yeah.
Star Wars or Star Trek?
Oh, Star Trek. Absolutely.
I think that's
absolutely. We still, the in the States, the even the original series is widely rebroadcast. You can always find it on. So the original, you know, with Shatner chewing on the scenery, is still as popular as it ever was. Absolutely.
Picard has to be the best captain, but there you are.
I don't know.
What's your favorite?
Shatner was just so smug and smarmy. I mean, you know, he just went into space, for God's sake. You know, they just Musk or Bezos just put him on a rocket. So, you know, how cool is that?
And what's your favorite film of all time? Favorite movie?
Oh God. All right, I'm going to throw this out there. I don't know how recognizable it would be to you. Buckaroo Banzai Across the Eighth Dimension. Do you know this movie?
No.
Oh, you don't. You have to.
Sorry.
It came out in the 80s. It was a science fiction film. It was one of those movies that's good because it doesn't realize how awful it is. But it has a cult following. Peter Weller is in it, Jeff Goldblum, John Lithgow, Ellen Barkin. It had an all-star cast, and in the 80s, these actors were already pretty famous. And it's a wonderful, and they're all scientists battling these aliens. And I recommend you look it up. But I like films of that ilk. I like Brazil, things like, you know, movies like Brazil, anything Python-esque, anything like that. Absolutely.
So on to more serious things. Not so dissimilar. What's your favorite? I think the answer is going to be obvious. What's your favorite conference?
My favorite conference. I like, obviously we all, you know, we just had the Cyto conference, the International Cytometry Conference, which is always very well done. It's been a real challenge the last few years with 2 consecutive virtual meetings that really threw us off our stride. But it's always a very, it's a wonderful conference, I think, because it caters to so many people. It caters to the hard scientists out there, but the core facility managers, the students, they try. I think ISAC has a pretty good idea of who their membership is or who they want their membership to be. But actually, one type of conference I go to are the optics conferences, photonics West, for example, which is the big one in the US.
Yeah.
The Munich one is I've never been, but it's even bigger, and it's wonderful to get the sort of physical science perspective on our technology. And the scientists out there, the physicists and the engineers and such, are very receptive to talking to me about this because they know nothing about biology, but they do understand how important their technology is to biology. And I've been able to tap into a lot of resources from them. We do a lot of laser work in my lab, and that would not have been possible without the cooperation of these photonics companies who often didn't even realize just how important their work is to us in biology. And they're eager to talk to us. They very much want to cross, you know, disciplinary lines and do more with us.
Which brings another important, what you just said brings another important point. You run a core facility, but you do have a small bit of research going on, sort of R&D tech-wise within it. How do you balance that?
We do. It's very small. I'm not a professor. I'm a staff scientist, so I'm really not supposed to have my own research program. But we do have a small R&D effort that is aimed mainly at instrument technology. So I've sort of told my bosses, look, I won't try to do, you know, biomedical research, but let me do things that will enhance the equipment that you're already using in your work. So we try to keep it very focused on specific research problems that are going on at the NIH. Someone needs to look at a particular fluorescent protein or something, a novel fluorochrome. So that's really how we've balanced it. We've tried very hard to make sure that our institution recognizes that this is not taking valuable time away from the science. And I've been fortunate. My administration has been supportive of it. They've funded it. And we probably dedicate maybe 10 or 20% of our time to it. But it's fun. It's something that's enjoyable for us, and therefore we're willing to take the time. And I think most of our investigators realize the benefits then.
And I'm going to put words in your mouth as well. York's also been very good at supporting that sort of initiative as well. It's not for the fun necessarily, because it also enhances the impact to the end users, to the scientists. There's always benefits. Yeah, the end user. It's not done just for fun. You say it's for fun because it is. It keeps you engaged. It helps you keep you up to technology edge. It keeps the companies that are putting instruments in interested in your facility, which is also beneficial. But yeah, it is as you say, you are picking samples off users, using them to help. So it's always that end user benefit, which I think is really important. What's your favorite technique?
I actually, when I was a student back in the 1990s, I did a lot of calcium measurement.
Ooh, I thought you were going to say apoptosis.
Remember Indo 1? Indo 1 was designed, it's a dye that was designed by Roger Chen, who's sadly now deceased. But Roger Chen designed many of the tools that we now use in biomedical science, fluorescent tools. He's known for GFP, but he did many things. And this was one of his, to measure what at the time was really the only way to measure very early activation in lymphocytes, in the first 5 minutes or so, by looking at calcium release, both calcium influx into cells and release of calcium stores. So he designed this very elegant biosensor that would change its spectral properties in the presence of calcium. And it was a tricky technique to get going. And I got it going pretty well. So I was very proud of it. And it's one that keeps popping up periodically, even now. We have better tools now for looking at T cell activation. We can look at stats, JAK stats, and things like that. But periodically, someone will come to us and they will say, we want to look at this, very, very early event in T cell activation that literally takes place in the first 30 seconds. And you can look at it by flow cytometry. So it's a technique that always has had sort of a soft spot in my heart, because we were good at it, and it takes a little practice to get going. And the data is wonderful when you get it. It's, this is really happening. Cells are really doing this. There's nothing inferred about it. And it uses a wonderful tool, a wonderful fluorescence tool that has been around for a while.
Yeah, we still teach calcium on our flow course.
Oh, good. Yeah. No, it's very much it's a wonderful way to show how you can really leverage flow cytometry. It's not just is something bright or dim, but it's looking at ratios and excitation and emission and things like that. It's a cool technique even today.
And it uses time as a parameter.
Yes.
Every application does. And wow, you have to clean your cytometer between samples.
Yeah, because that little bit of mitogen in there, that picogram level is still enough to hit that T cell. It teaches you a lot about the how sensitive these systems are and such.
Bill, we are up to the hour, so we have to stop. But I had a few other questions I wanted to ask, which I'm not going to get to ask. I'm going to one more question, because
sure.
Who has been, scientific? Who has been your inspiration? Do you have any one or two people who have been your inspirations that you can give a shout out to?
Absolutely. Well, I mean, I'll quickly say this very shortly. You mentioned Howard Shapiro, who was really one of the founders of flow cytometry. He was important in popularizing it, really, writing his books and making sure people knew about this technology and how it could be employed. And I was lucky enough to know Howard before he passed recently. I mean, he's an inspiration for many of us, of course. But I will mention my flow mentor is a man named Lewis King, who's still very much around. Lewis ran the flow lab at Michigan State. He ran our ancient orthocytofluorograph. Lewis was well connected to a lot of the Midwestern U.S. cytometry people, like Paul Wallace, Paul Robinson, and such. And he was a fantastic teacher to me. He really taught me how cytometers work. And I've always sort of, he was like a postdoc in our lab. He wasn't a professor, but he I always kind of attribute the fact that he was the one who convinced me I could actually do this for a living, that it didn't just have to be another technique to use in my research, but I could actually, do this as a career. So I just want to shout out to him because he made a very big difference in my life and taught me a lot about how flow works.
Bill, thank you for that. And thank you for joining me today. And actually, for those who are listening, maybe Bill's just inspired you now to realize there is a career in this technology platform, and it is a developing market that's got a long way to go. So we may have talked about the risk to our facilities, but trust me, it's a minor risk compared to where this is going. So, and if you're a data analyst, gosh, we need you desperately. So Bill, thank you very much. If you enjoyed this, go back and look at the others. There's Rachel Errington that we've heard of, shout out to Paul Robinson. All those are previous guests, but Bill, you've been so easy to talk to. And
had a great time.
If you've got some spare cash, anyone, there's some real big initiatives out there in helping support science across the world. So have a think about that as well. Bill, thank you.
Thank you. Thanks for having me. Had a great time.